Hi everyone. So this video today is going to be talking about graphing polynomials, okay, especially in factored form. Okay, so now this first example, this is from the homework that was from block day, which was Wednesday and Thursday, the 26th and 27th of January. Okay, so this first problem right here, f of x is the same thing as y, and there are three distinct x-intercepts or three distinct roots. Okay, so we're going to look at the exponents that each parentheses have. They're not written here, but each one of these has the exponent of 1. So that what that means is the degree, okay, for this function is 3. So the highest total exponents is 3. I'm just going to get rid of those ones so I don't have to keep looking at them. Okay, so first things first is x to the third. It's going to behave just like x to the third, and I know that it's like x to the first, so it's going to be kind of going uphill, but with the little loops in the middle. So first things first, let's plot our dots. 1, 2, 3. My x-intercepts are -3, 1, 2, 3, 4, +4, 5, 6, 7, 8, 9, and +9. Okay. Now, so something to point out. We talked about in class the other day. We talked about this thing called multiplicity. Okay, multiplicity is just talking about um, how our graph is behaving at the roots. So if it's an even exponent, meaning each parentheses, if it's even, it's going to bounce off that point. If it's odd exponent, it's going to go through. So what I mean by that is, so let's take a look. This, I know my shape looks like this because it behaves just like x to the first. So I know the bottom left-hand side of my graph is going to go down and the right side of my graph is going to go up. It's basically like I took this straight line, and if I draw it over here, I separated it and I have this gap in the middle. So I want to fill the gap in the middle. So if I look at this root, this represents this x plus 3. The exponent with that parentheses is 1. So I'm going to go through my root, so I'll be above it. Now I'm approaching the x minus 4 root, so the 4, 0, and the exponent is a 1, so I know I'm going to go through, so I'll be down below it. And then this next root, the exponent is a 1, so I'm going to approach that root and go through that dot, so it flows nice and easily. Okay, so I'll do another example after, but that's just the basics of how to graph. The end behavior is looking at, okay, so this says my left side goes down towards negative infinity. This says my right side, and that's going up, and what's up there is positive infinity. The roots are at -3, 0, they're at 4, 0, and they're at 9, 0. Now, to find the y-intercept, you plug 0 into all my x's. So 0 plus 3, 0 minus 4, 0 minus 9. So that'd be 3 times -4 times -9, which comes out to be positive 108. Now, I know I can't graph 108 on my screen. As long as you show me my y-intercept is somewhere above 0, I'm okay with that for right now. If I gave you a y-intercept and I expect you to be able to graph it, I have to make sure it fits. Okay, so that's example number 1. Let's scroll down and take a look at number 2. Okay, so this polynomial here, if I add the exponents, which are 2, 1, 1 is 2, plus 2, the degree is going to be 4. What's special about that root is it's pointing out that it has this exponent of 2. That just means that it's going to bounce, like we kind of talked about multiplicity. Okay, so and it's going to behave just like x to the fourth, which is like x squared, so a U shape. So I know my ends will go up and up, but let's graph it to make sure. So my roots are at 5, 0, they're at 2, 0, and they're at -6, 0. So if I plot those, 1, 2, 3, 4, 5, 6, 2, 0, 3, 4, 5. So I like talking like a jigsaw puzzle. Graph the edges and then fill in the middle. I know my edges are going to go up on the left and up on the right. So up and up. And now I have to figure out the behavior of each root. So this -6, the root, has an exponent of 2. So I'm going to bounce up and off that point. So I'm now going to start heading towards my second root, which is +2. And now that exponent is 1. So I'm going to go through that root. So I'm down below it. And then the 5 has an exponent of 1. So I'm going to go through that root. And there's my W. Now, it's a more accurate graph than what we were just sketching the picture of. To find the y-intercept, you plug in 0 to each. 0 minus 5, 0 minus 2, 0 plus 6, that's 0